Well, welcome everybody. My name's Jack Kane, and we're going to be talking a little bit about the safe continuous delivery pipeline today. Here's the agenda. We've already done some of the introductions. I'll continue a little bit about my background, and then we'll dive right into the subject matter topic. So this is about me. It's kind of a busy slide, but I live in 3 different worlds. I live in the Scrum Alliance world, the Scaled Agile world, and the IC Agile world. I'm an accredited instructor for all 3. And I teach everything from DevOps to the various kinds of roles in Scaled Agile framework, to design thinking and Kanban and the like. Worked at lots of different companies, helped lots of different companies in coaching and training, big and small, and really have enjoyed my interaction with the folk. So, introducing DevOps. DevOps is kind of a strange thing because it doesn't actually have a clearly defined definition. But if you go to Wikipedia, which is a great place, right? There is their definition, and the way that it's defined is talking about a culture and a practice that unifies software development, both on the dev and the ops side. Now, dev says change, 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 and ops says stability, 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 and we have to create some type of environment by we're all pulling together. And that's what DevOps tries to do. And so it starts with that culture of shared responsibility. And then we go and we do automation and monitoring and integration and testing and releasing and deployment and all that kind of good stuff. So DevOps aims for some things. Yeah, and there are different kinds of people in an organization that are actually part of DevOps that you might not normally considered. When someone hears dev or they hear ops, they think about developers and operations people. But you know, who else might be in there? Well, there's the architects, there's the compliance folk, there's security, business, in addition to operations and development. So what we'd like to do is we'd like to shorten the development cycles, increase deployment frequency, make more dependable releases, and we want to do this in alignment with close alignment with business objectives. There are some other DevOps goals as well. If you go down this bullet list, your own organization probably has some of these goals, or maybe all of these goals on their to-do list. How do we go and do these types of things? So DevOps really helps get you there. And here are some of the things that some of the surveys have shown that people are actually achieving out there. So, you know, being able to have a faster lead time, going from concept to cash 440 times faster, that's a pretty significant thing, right? Being able to double your net promoter score from the employee's perspective. In other words, how well the employee is happy. This is the other end of the spectrum. For, you know, we have the performance folks in the industry, and then we have the sustainability folks in the industry. So these are 2 key goals that people have been looking for, and DevOps has been helping them get there. So in SAFE, we have something called CALMR. It's an acronym that stands for Culture, Automation, Lean Flow, Measurement, and Recovery. And as I mentioned before, SAFE and DevOps starts with a culture of shared responsibility. So this is a shared responsibility for development, deployment, and operations. And then we go and automate the continuous delivery pipeline. And I'm going to walk you through what that means, the continuous delivery pipeline, a little bit. And we'll talk a little bit about the automation that occurs in that. Now we got to look at the flow. So we pull from lean to to manage the flow, we do this first by keeping batches small, by limiting the amount of work in progress, and then providing extreme visibility. And for those of you that know the Kanban method, we use Kanban within SAFe, and DevOps certainly does as well. Once you are visualizing it, then you have to measure it. So what is the flow through the pipeline? And so there's all this telemetry that has to be built in to do that. And we have to think about that from the beginning, not as an afterthought. And then there's recovery. We have to architect and enable low-risk releases, establish fast recovery and fast reversion. And we also have to be able to have a way to do some fast fix forward. So we're going to talk about CALMR in the delivery pipeline that SAFe uses. So here's a nice little graphic on CALMR. Again, CALMR is SAFe's approach to DevOps. Now, SAFe is the Scaled Agile framework. And you can see the entire framework at scaledagileparamework.com. It's an interactive website. So when you go there and you see this, you'll notice that there are some tabs up here for the different configurations. Essential, large solution, portfolio, and full. What we're seeing right here in this PowerPoint slide is the full configuration for SAFe. Now, many organizations don't need all four levels. You'll see there's a portfolio, large solution, program, and team level. Many just need the program and team level, and that's actually where DevOps lives. So the continuous delivery pipeline and DevOps live in the program level in the Scaled Agile framework, and SAFe bridges the gap between Agile and DevOps. It brings it all together. And so there's a core competency called the DevOps and Release on Demand core competency in the Scaled Agile framework. And that's what we're going to be focusing on today. So the first thing you always want to do when you're thinking about your pipeline is you want to map it out. And so the way that SAFe does it is we think of the things as interlocking continuous cycles of exploration, integration, deployment, and the capability of releasing on demand. So the idea is that something should be able to go through all of these cycles plus the release on demand within a 24-hour period. So think about all the steps that you have in going from concept to cache. What do you have to do? All the individual steps and the like. And so this is where we come up with value stream mapping. SAFe uses the concept of value stream mapping to map this out. There's a really great book, it's called Value Stream Mapping by Martin and Osterling. And in that book, they talk about mapping out your current state and then later on mapping out what a future state might look like. So let's look at the current state first. It's a step-by-step process in creating your value stream map. So the very first part of it is identifying the individual steps going from concept to cache. Now, some people like starting when they're drawing out this value stream map, the steps in it, they like starting at the end. So in this particular case, it's production sign-off. And then they work backwards. That's a really good way of doing it. But regardless of how you do it, going from the beginning to the end or the end to the beginning, you would identify the steps. Once you do that, then you identify the people that are associated with each step. And you also probably want to identify how many people are involved, the roles they have, how many, etc. The third step is to measure the steps. So we have 3 different measurements that we want to do at each individual step. The first one is process time. The second is lead time. And the third is something called percent complete and accurate. So PT, LT, and percent CNA. So the interesting thing about lead time and process time is that if they were equal, you would have a 100% efficient system. But rarely do we have that type of situation, not only on individual steps, but throughout the entire system. So lead time equals process time plus wait. And of course, wait is a type of waste in lean. Regardless if you're doing software development, manufacturing something, or delivering a service, think of all the wait states that occur at each step in your value stream. So in this particular case, we have a feature definition that has 100% efficiency in comparison of the process time and lead time, 4 hours and 4 hours. But if you go to the next one, it's much different. Process time was only 4 hours, lead time was 8. So there was 4 hours of wait in that second step on the design step there. Now you'll see also in this example that the percent complete and accurate for the first step is 75%. The way that you figure that out is by going to the next step. So in this particular case, we're figuring out what the percent complete and accurate is for the feature definition step. We would go to the next step, which is the design step, and say, hey, when we give you our stuff from feature definition step, what percentage of the time is it complete and accurate? If they say 75%, that's what you would put. 75% complete and accurate. That means 25% of the time there's a problem. It's incorrect. The information is not good. A value stream is not just about the product that flows through the value stream. It's not just about the people either. It's also about the information that flows. So when things are not complete and accurate, that means rework, and it affects the efficiency and flow of the system. So you'll notice here also that on the design step, there's two different percent complete and accurate. There's one that says 80% and another one that says 70% UAT. What that means is that initially we thought that it was 80%, but when we got to the UAT part, we realized that it was actually lower. So we would always use the lower percentage for complete and accurate when we're trying to figure out our systemic metrics. And that's the next step there, is to calculate the system metrics. So we're going to sum up the process time. We're going to sum up the lead time. We're going to divide process time by lead time and times 100, and for that sum total, and that's going to give us that activity ratio. So that's a real eye-opener when you see that, because that shows efficiency of the system. And then what we're going to do is we're going to look at the percent complete and accurate for every single step. So in the current case, feature definition was 75%. We would use 0.75, and then the next one is 70%, so that would be 0.7, and etc. So we would times all those and times 100, and that's the rolled percent complete and accurate. You will be amazed when you see that number when you do your value stream mapping exercise in your context. You will see that both the activity ratio is a very low number, so where you're starting out at, and so will be the rolled percent complete and accurate. Don't be dismayed by that. The benefit of doing this is to see where you're at. You have to understand where your current state is before you can then think about what the future state should be. So this is the first step, is the current state. And we would do the same thing, but we would make changes in our steps or how we would do things. So maybe we would include different types of automation, different types of automated testing, might be doing tests first, all these different things that we might do as experiments, and then figure out what the systemic metrics might end up being in that future state. So we're going to visualize the flow of value in this way. We're going to do this value stream mapping, and continuous delivery is the hope is that we're going to visualize that flow of value from concept to cash. And after we have visualized it, then we're going to want to evaluate it. So SAFe has this thing called the DevOps Health Radar. And as you can see here, there are the 4 major dimensions that were listed before: continuous exploration, integration, deployment, and release on demand. And then there are sub-dimensions for each of these dimensions. And it's a spider map. So if you're closer to the bullseye, that's better. If you've got a 5 on something, then that basically means that there's work to be done in that particular sub-dimension. So the idea is that we can complete a full pipeline cycle in 24 hours. So ask yourself, can your teams do that? If not, then there is room for improvement. And the DevOps Health Radar allows you to self-assess and to build a plan towards that. We're going to come back to the Health Radar towards the end of the webinar. Here again is another visualization of the continuous delivery pipeline. In SAFe, this is a program level view. We have these things called PIs, which stand for program increments. And in a program increment, you have these continuous cycles continuously occurring, plus release on demand. So you see on release on demand and by the way, a program increment is typically 10 weeks long. So during a 10 weeks long, you might release multiple times. Now, some organizations, they release multiple times per day. In enterprise work, that typically doesn't happen. It typically happens in a longer time box, maybe 2 weeks, maybe 4 weeks, maybe 6 weeks, something like that. That would be according to what your business needs are. So we have all this stuff going on in a continuous basis, and that is the key. Continuous delivery pipeline is continuous. Now, in those cycles, we have to do continuous security and testing as well. So here we have some on the DevOps Health Radar. You'll see that in the different subdimensions, there are different activities that we can continuously do, like threat modeling, using security as code, doing penetration testing, and the like. I really like the stuff on the right-hand side over here. I'm a big fan of behavior-driven development and test-driven development, these being agile engineering practices that start in continuous exploration and continue in continuous integration. So there's all these different continuous security and testing things that we can do and that we should measure as well. So I've been talking about these dimensions, the first one being continuous exploration, and the big thing that we're going to do in this dimension is to gain alignment. So here's a bigger view of what happens in this particular cycle. We have these subdimensions of hypothesis, collaboration and research, architecture, and synthesis. And many of you may have a background in design thinking. So, you know, seeing some of the things under the collaborate and research you'll be familiar with. You also may realize that if you're doing Agile, you know, Agile starts with the hypothesis, but where does that hypothesis come from? You know, all of Agile and Lean, we do empirical process control. So it's hypothesis, run an experiment, inspect and adapt. You may also know it as plan, do, check, adjust, or plan, do, check, act, or plan, do, study, act. There's variations of that in the industry. In SAFe, we do plan, do, check, adjust, and we have to start with the hypothesis. So Agile really doesn't tell you where the hypothesis is going to come from. In fact, if you've been doing Scrum, you go to the Scrum guide, there's no guidance at all as to how to create that hypothesis. So SAFe takes this one step above and has this continuous exploration cycle that uses design thinking techniques to generate these great ideas. And we do this in various ways through the lean startup cycle and also lean UX. The collaboration and research continues that on, and then we're going to use, we have to plan for architecture as well. We do want to do just enough. And there's certain things that have to be built in and thought about before going forward. We don't want to do big bang upfront planning, but we do want to build in some things and use certain types of models to help us understand what our roadmap is actually going to be. In fact, the hypothesis, the collaboration and research, and the architecture work that we do in the continuous exploration cycle is synthesized into a vision and a roadmap, and then a program level backlog that we can visualize on a Kanban system, and which we can sequence work based on something called WSJF. That stands for weighted shortest job first. You'll see that right here over the Kanban board in the synthesis subdimension. Weighted shortest job first is the cost of delay divided by the size of the work. All of this goes into something that we call PI planning. We do this every 10 weeks. This is program increment planning, and it is a high-level plan for the next 10 weeks for the program. So this is the continuous exploration. You know the saying, garbage in, garbage out, right? So if you don't do good stuff here, it will affect your continuous delivery pipeline. It will gunk up all the good things that you're want to do in the in all the automation. Even you may not even automate the right thing if you're not doing good continuous exploration. So in summary, we have the lean startup, minimum viable products and innovation accounting that are associated with deciding whether or not we should pivot or persevere. We start with the hypothesis and we do experiments. We are going to use lean UX, minimum marketable features, and research and collaboration. This is all design thinking kinds of stuff. Both these two things, lean startup and lean UX, are incorporated into the scaled agile framework. They come from, these ideas come from two different books, Lean Startup and Lean UX, really good books. And they too, both those cycles are built on empiricism. And then we have in the architecture, we're going to decouple deployment from release. And we do this with streamlets, and we use things like microservices, APIs, feature toggles, containers, and strangler patterns to enable this ability. So when we're talking about decoupling deployment from release, what we're saying is that we want to be able to deploy to production individual types of things, not just the entire new version of a platform. And so, for example, we may want to deliver a security update based on a release on demand. You know, it's very, very important that we do it very quickly. However, we may want to do every 2 weeks end user functionality and maybe an entire solution once a quarter. So that's why we decouple deployment from release. Now, this also allows us to do things like dark launches, and I'll talk about those later. Then we have the threat modeling and architecting for testing and telemetry. Got to do that as well. And lastly, we're going to roll all this stuff into a synthesized vision roadmap. We're going to have features in a program level backlog. We're going to sequence those features by WSJF, weighted shortest job first. We're going to do this PI planning and use behavior-driven development for validation of our functionality. I'll talk more about BDD, behavior-driven development, in a little bit. The next thing we got to do is we got to build quality in, and we do this through the continuous integration cycle. So this is the second dimension on the health radar. You'll notice that it has 4 subdimensions: develop, build, test end-to-end, and staging. So let's look at that. Here's a bigger view of it, and so you can see what it looks like. And let's go through this a little bit. So the first thing we want to make sure that we have is some version control. And in Safe, we don't use feature branches. We use feature toggles. So everybody needs to know how to use a mainline branch and feature toggles. We're also going to use pair work, test-driven development, telemetry, and of course, vertical slices. A vertical slice is typically identified by user story, where you have a slice through the front end, the back end, and the database. That's one small unit of work that can be deployed independently from others. The test-driven development is automated unit testing. Automated unit testing is test first. We write the automated test script first, then we write the code. So it's a cycle of writing the test, writing the code, refactoring, and doing that until the test passes. Next, we're going to have continuous code integration, and we're going to do this with gated commits. And we do that so that junk doesn't end up in the main line. We're going to use that trunk-based development with the feature toggles that I mentioned before. And we're going to use build and test automation. Now, in order for all this to work easily, we're also going to use something called test doubles. You may know these as masks and mocks. We also have to do some end-to-end testing. So there's a bunch of ways that we can do that, including automated static code analysis, test matrices, version controlled test data, and non-functional requirements. It's actually important to understand that everything should be under version control, including your test data. Often it will cause all kinds of grief if you do not do that. Configurations also should be under version control. Then we're going to deploy to staging. So, when I ask people, when does continuous integration start and when does it end? Some people have a hard time understanding this, but it's really quite simple. It starts when a developer commits code to version control, and it ends when we deploy to a staging environment. Now, staging environment is a production-like environment. It has similar data, similar configurations. So we are basically looking at a production environment that we can then do demonstrations to our customers. Now, deployment to staging, it can be done several different ways, but in a scaled environment, it's very important that we show a system demo in that environment. And service virtualizations, doing blue-green deployments and things like that, these are very beneficial for deployment to staging, and then also in reference to blue-green deployments, going deployments to production. Now, deployments to production is actually part of the next cycle, which is the continuous deployment cycle. We'll get to that in a sec. So often what will happen is organizations will go and start doing Scrum, and they will work with small batches. They'll decompose big stuff into little stuff, and this little stuff is our user stories that get done at the end of a iteration or sprint. And then these work items, which are done, sit in a queue, and they wait there, and they wait there, and they wait there, and they wait there for a tremendous amount of time before they're actually deployed into a production environment. And continuous deployment means that we deploy to production, but it doesn't mean that external users can actually use what we've put into production yet. What we want to do is we want to continuously be able to put things into production and then test it with synthetic users so that we decrease risk. And so let's dive into this a little bit. So here's a bigger view of the 4 subdimensions in the continuous deployment cycle. deploy, verify, monitor, and respond. So we're going to deploy to production, but we're going to do it in what's called a dark launch way. So, the best example of that, probably the most well-known one in the industry, is Facebook Messenger. So Facebook deployed Facebook Messenger to production. It was in production for a year, but no real users were using it for that year. The company had synthetic users that would ping the heck out of the application in foreground and background ways to see what the impact on the production system would be. You don't really know what it's going to be until you get it into production. So they had it in production, it was on their production servers, but it was only the synthetic users that could that had access to the application. So they could monitor it very easily to see what the impact was going to be and dial back the number of synthetic users when there became a problem. And then they would stop it. They would go and make changes, go through the continuous delivery cycle again from exploration onward, and then deploy and start over. And then after a year, that's when they launched it to the public. That's when they made it. That's when they released it to the public. So this is a clear explanation of how we decouple deployment from release in Scaled Agile framework. So we have, in order to do this, we need to have what's called feature toggles. So we're going to have a mainline branch. We're not going to have feature branches anymore. And we're going to use these toggles to turn things on and off in different environments. Probably Facebook is one of the kings in this area. They have tremendous usage of feature toggles to allow different kinds of users to see things in different kinds of environments. So we're going to need some deployment automation to do all this stuff as well. So this is part of this particular cycle, and we're going to do selective deployment of what we're going to deploy. And again, that comes from the streamlet concept. Synthetic user testing in production, as I mentioned, this is to verify whether or not it's actually working. And then we've got to monitor stuff, so we have to have some full stack telemetry, visual displays, and federated monitoring. All of these different types of techniques are explained in greater detail in the Safe DevOps Practitioner course and in many books as well. So lastly, we're going to have to respond. This we need to do through proactive detection, cross-team collaboration, session replay, rollback and fix forward, and immutable infrastructure. I'd like to just clarify what a couple of these things are. The session replay is basically where someone is videotaping or taping the session that is, the step-by-step session that a synthetic user goes through or an actual user goes through. And by watching this, by videotaping it, then developers can say, oh, look what's happening. They can see it. The immutable infrastructure, you may not have heard this term before, but what it means is that everything starts in version control. In other words, no more FTPing directly to a production server. I've seen some studies that have shown that when you compare the configurations and the code in production versus staging or other environments, that it's so different, like 50% different, which is really scary because when people are FTPing and patching stuff directly and it's not going through a continuous delivery pipeline starting with version control, you really have no control over what's going into production. And so the idea with immutable infrastructures, everything goes through this. Everything starts through version control. It's going to go through the continuous integration cycle, through the continuous deployment cycle, and then release on demand. So here we are in release on demand, and that's where business value is actually used by people. Until this occurs, you haven't gone from concept to cash. Now, there are several parts to the release on demand. The release, the stabilize and operate, measure, and learn. That learn cycle is associated with two parts. The first part is validating the hypothesis of lean startup, which is my customer delighted? And there are subsequent validations of hypotheses as well that are associated with the user. This comes from Lean UX, and we ask the question, are users delighted? So we need to do that in a production environment as well. So one of the ways to do that is something called the canary release. It comes from the canary in the coal mine type of thing. You want to kill the canary before you want to kill the people. So you would release to specific live people, but they would be internal people rather than your actual customers and users in a production environment. You would eat your own dog food, so to speak. Another way of doing it is, well, before we get to failover and disaster recovery, another way of doing it also is to use those feature toggles to only allow specific demographics to use the system in production. And by rolling it out in this way, either by demographics or by geography or the like, you decrease risk. If you find that there's a problem along the way, there must be a recovery process. And the only way you can really do that is if it's automated. There are various ways to do this. We teach you in the course how to do this. Of course, you have to monitor the security. This has to be done in a continuous fashion. And the way that things, when you have the federated measurements, the telemetry, all these panels that show what's going on, it's much better when everybody sees what's going on very quickly. I already spoke about the hypothesis validation. There's a concept in Lean Startup called innovation accounting. And innovation accounting are novel measurements, novel practices. A standard one is Net Promoter Score. That comes from a book called The Ultimate Question. On a scale of 1 through 10, how would you rank my product, service to family, friends, coworkers, etc.? A 9 or a 10 is a promoter. A 7 or 8 is neutral. Everything else is a detractor. You need 10 to 20 promoters to offset 1 detractor to offset impact to your brand. And there's something called good profit and bad profit. So if you're charging a lot and they have nowhere to go and they're bad mouthing you, they're giving you low scores on the NPS, that's bad profit. And you have to do something about that. So innovation accounting are novel practices. You basically have to dream up the metrics based on the context. Sometimes that's easy, sometimes that's hard, and you need some help from the outside to help you do that. Lastly, we need to learn. We do this through relentless improvement, value stream mapping for the future state validation. So, the relentless improvement is part of the house of Lean, SAFE's application of Lean, and this also has to be implemented for release on demand to work. Now, once you're wherever you are, you start wherever you are, you probably want to take some type of assessment, and then you need to take some action. And so I'm going to talk about that process. So again, here is the health radar for Safe DevOps. So there are a series of questions that are asked for each individual subdimension so that you can self-assess. And here are some of them. And so, we would go through this and just self-assess. Now, this could be done by one person, or it could be done by a group of people trying to do some problem solving. I suggest that it be done by several people or lots of people in the program so that you get a full understanding of where everybody thinks everything's at. Now, once you do that assessment and you have that radar filled out, you can see where the gaps are, and you see where what you think is the problem. And so you can use that as an input to a problem-solving workshop. Now, in SAFE, we have every 10 weeks an event called the INA, Inspect and Adapt. And inside of the Inspect and Adapt is a problem-solving workshop. And it starts by agreeing on the problem to solve. So we can take from the DevOps Health Radar where we scored poorly, and we can say, okay, we have a problem here. Then what we do is we run it through an Ishikawa diagram exercise, also known as the fishbone, and that's what we have here in the second box here. So this is people, process, tools, program, and environment. Environment means culture. And so we ask, from the perspective of this problem and the perspective of each bone in the fishbone, why did this happen? We ask it five times. That's the 5 whys. So from a people perspective, why was insufficiently reliable release commitments done? And we ask that 5 times. We do that from a process perspective, tools perspective, program perspective, and culture or environment perspective. And so then we have 25 different root causes, potentially, because there's 5 times 5. And we then do something called dot voting. So we can all vote to see which causes are probably the biggest causes that we think they are. And we do this in a group of people. And from that, we can build what's called a Pareto analysis. So Pareto was an Italian economist. He found that 80% of all the land in Italy was owned by 20% of the people. Said, oh, that's interesting, a ratio. I wonder if that applies to anything else. Turns out it applies to a lot of stuff, including when you're doing problem solving. So you look at the 80% votes, 80% of the votes. It's probably going to be 20% of the causes, and then you're going to want to restate your new problem based on that biggest root cause. Do some brainstorming, do some dot voting again so you can prioritize it, and the top 1 or 2 things end up in the improvement backlog, which is an input into program increment planning, which occurs the next day. So this is this problem-solving workshop you can take the SAFE DevOps Health Radar assessment that you did before, use it as an input, run it through this workshop, and then plan out the work. And so it's going to end up, that work, those ideas, that solution is going to end up in the funnel in your program Kanban. And you, of course, need to show the flow of that improvement through that. So we've added these things into the funnel right here in the Kanban board. We're making work visible. We see it moving in the program Kanban system. We use WIP limits so that we don't get overloaded. We use WSJF along the way to sequence the work that we're actually going to work on. And this requires the product manager, release train engineer, system architect, and system team to be involved, as well as the business owner. The business owner is going to be especially involved in the WSJF sequencing of work. Also, what we want to do is we want to implement some capacity allocation at the program level. So the way that works, it's an agreement between the system or solution architect or engineer and the product and solution management folk, plus the business owner. And this agreement is usually facilitated by in SAFE, we call this a release train engineer. It's kind of like a chief scrum master, a chief facilitator. They facilitate the discussion of this agreement. And so we say, okay, a percentage of the next 10 weeks of these 50 to 125 people is going to be dedicated to enablers other percentage to technical debt and maintenance, and that way you're not creating a monster. And this agreement is done before we come into program increment planning. So, becoming a safe DevOps practitioner. If you like what you heard so far, you might want to take it to the next step and go and do this. There are many people that can benefit from this. Any member of the Agile release train, this course doesn't require heavy-duty developer knowledge. This course is based on two major things. The first one is value stream mapping, and the second is the health radar. So anybody on the Agile release train, this includes product managers, product owners, and process-related people that are experts in the process of SAFe, like the Scrum Masters and RTEs. But of course, technical people are going to benefit it as well. I highly recommend this for managers and for those that own the value stream. If they go through this, then they will understand the benefit of making work visible. This is a certified course, so there's an exam associated with it, and it's a 2-day course.
We are Starweaver. Education you can bank on. For more information, contact us.